Hello everyone, I am Yashina. Today I will be presenting to you on the topic recent trends and issues in computer networking. On this topic, a research paper has been made. This article discusses the growth in network usage and recent trends in networking technology, including software-defined networking, SDN network, 5G network, the Internet of Things and edge computing. This article also mentions other networking trends and recent issues faced by the users such as slow connectivity, capacity concerns, security issues, host identification, and performance degradation. The growth of internet has permanently changed networking. Millions of individual users access the internet from regular. Home offices are on the rise and businesses are using the internet for commerce. There is an increasing trend of organizations maintaining their own intranets. Now in the further slides, I will be explaining to you about some of the recent trends. SDN (Software Defined Networking) technology is an approach to network management that enables dynamic, programmatically efficient network configuration in order to improve network performance and monitoring in a manner more akin to cloud computing than to traditional network management. SDN is meant to address the static architecture of traditional networks and may be employed to centralize network intelligence in one of the network components by disassociating forward process of network packets data plane from routing process control plane. Now next is the 5G network. In telecommunication, 5G is the fifth generation technology standard for broadband cellular networks, in which cellular phone companies began deploying worldwide in 2019 and is planned successor to the 4G networks which provide connectivity to most current cell phones. 5G networks are cellular networks in which the service area is divided into small geographical areas called cells. All 5G wireless devices in a cell communicate by radio waves with a cellular base station via fixed antennas over frequency channels assigned by the base station. The base station is termed as nodes are connected to switching centers in the telephone network and routers for internet access by high bandwidth optical fiber or wireless backhaul connection. IoT, the Internet of Things, describes physical objects with sensors, processing ability, software, and other technologies that connect and exchange data with other devices and systems over the Internet or other communication networks. Internet of Things has been considered a misnomer because devices do not need to be connected to the public Internet. They only need to be connected to a network and be individually addressable. A growing portion of IoT devices is created for consumer use, including connected vehicles, home automation, wearable technology, connected health, and appliances with remote monitoring capabilities. IoT devices are a part of the larger concept of home automation, which can include lighting, heating, air conditioning, media, and security system. Basically, the smart home system that are currently in use in the present time. IoT technology is more synonymous with products pertaining to the concept of home, including devices and appliances, home security system, cameras, and other home appliances that support common ecosystem and can be controlled via devices associated with the Wi-Fi technology or Bluetooth technology such as smartphone and smart speaker. IoT is also used in healthcare system. Edge computing is a distributed computing paradigm that brings computation and data storage closer to the sources of data. This is expected to improve response time and save bandwidth. Edge computing is an architecture rather than a specific technology and a topology and a location sensitive form of distributed computing. Edge computing brings analytical computational resources close to the end users, therefore can increase the responsiveness and throughput of application. A well-designed edge platform would significantly outperform a traditional cloud-based system. Some applications rely on short response times, making edge computing a significantly more feasible option than cloud computing. Examples range from IoT to autonomous driving system, any health or human public safety relevant or involving human perception such as facial recognition. Other trends in networking include botnets, network security, wireless networks, and network virtualization. Now, the fifth trend that is currently in a booming is the botnet. A botnet is a group of internet connected devices, each of which runs one or more bots. Botnets can be used to perform distributed denial of service attacks, steal data, send spam, and allow the attacker to access the device and its connection. The owner can control the botnet using command and control (CNC) software. The word botnet is a portmanteau of the words robot and network. The term is usually used with a negative or malicious connotation. A botnet is a logical connection of internet-connected devices such as computers, smartphones, or Internet of Things devices whose security have been breached and control ceded to a third party. Each compromised device, known as a bot, is created when a device is penetrated by software from a malware, malicious software distribution. The controller of a botnet is able to direct the activities of these compromised computers through communication channels formed by standards-based network protocol such as IRC and Hypertext Transfer Protocol (HTTP). Botnets are increasingly rented out by cybercriminals as commodities for a variety of purposes, basically in the form of viruses in the CPUs of many distribution users. Now the recent trend which is in our sixth position are the wireless networks. A wireless network is a computer network that uses wireless data connections between network nodes. Wireless networking is a method by which homes, telecommunications, networks, and business installations avoid the costly process of introducing cables into a building or as connection between various equipments location. Admin communication networks are generally implemented and administered using radio communication. This implementation takes place at the physical level of the OSI model network structure, which we have studied in detail in the class. Example of wireless network include cell phone networks, wireless local area networks, VLAN, wireless sensor networks, satellite communication networks, and terrestrial microwave networks. Now the seventh trend is the network virtualization. In computing, network virtualization is the process of combining hardware and software network resources and network functionality into a single software-based administrative entity, a virtual network. Network virtualization involves platform virtualization, often combined with resource virtualization. Network virtualization is categorized as either external virtualization, combining many networks or parts of network into a virtual unit, or internal virtualization, providing network-like functionality to software containers on a single network server. In software testing, software developers use network virtualization to test software which are under development in a simulation of the network environments in which the software is intended to operate as a component of application performance engineering. Network virtualization enables developers to emulate connection between application services, dependencies, and end users in a test environment without having to physically test the software on all possible hardware or system software. The validity of the test depends upon the accuracy of the network virtualization in emulating real hardware and operating systems. Here are some images depicting the various trends in networking. Now in the further slides I will be explaining about the recent issues that is currently faced in the networking field. Slow connectivity. Slow connectivity over a network is more frustrating where a simple task takes a long time to be performed over a network. It's often caused by large file transfers over a large area through network. It becomes an unwanted challenge for users when they work over computer network. Second is the capacity concern. Nowadays, volume of data is so high which is produced from various sources. So network capacity also needs to grow with respect to it. Today, we are dealing with trends like Internet of Things, big data, data science, etc. And next year, something new will also be added. So networks also need to be improved. Capacity needs as well as facing cyber threats. The third common issue is the security issue. When it comes to computer networks, there is security issue arises. It is one of the top issue of computer network and a big challenge to network security engineers, which generally involve protecting network from different cyber attacks by preventing unauthorized users to enter and access the system and maintaining the network integrity of the organization. All these security issues increases with increase in network size. When network size is larger, their chance of security issues are more, since it becomes more complex to be handled by the security engineers. Fourth is the host identification. Small networks can be easily configured with the help of manual addressing, but this becomes a serious problem in large networks when it comes to host identification, because without any proper address of networking, it becomes most difficult to establish communication in a network. So proper host identification is necessary for a network communication. Now, the fifth most common issue which we face is the performance degradation. Many times we have faced loss in data integrity and speed of a network, which is generally down due to poor transmission and is also known as performance degradation. Every network that may be large or small performance issue is everywhere, but in large networks, this performance degradation is issue as high communication has to be established within a larger area and also by help of many network devices. This performance degradation comes in the form of packet losses. Monitoring and maintenance is the sixth issue. Monitoring and maintenance of global network is one of big challenges of current time. It becomes very difficult to monitor volume of traffic in a large network. Physical connectivity issues, excessive CPU usage are some of the other issues in computer networking. Now the seventh issue is the physical connectivity issue. A network connection can suddenly break because of physical connectivity issue. A common problem is when a network cable becomes damaged or knocked loose. Cables might be added or removed from a switch and one of the other cables might accidentally get disconnected. Or a cable was damaged when it was pulled around a sharp edge while work was done on heating or air conditioning pipes. It should be clear from the segment of the network affected which cable was damaged. But finding a problem along a cable stretching across the ceiling may be time consuming. Excessive CPU usage. Task Manager is the first thing to use to find which application is using a high proportion of the system resources, such as CPU, memory, or disk space. This basic troubleshooting step may not reveal a problem, since some application may be performing complex calculation, receiving high-speed video, or interacting with large databases. A virus may also consume resources, so make sure antivirus is up to date. If an application has been running for a long time, it may slowly leak resources. The quickest way to improve performance is to stop and restart the application. Although sometimes you may need to stop and restart the entire system. Updating device driver may also improve performance. Task Manager also shows applications who didn't know were running in the background. One example would be Windows including games upon system startup. Editing startup files can eliminate this problem. The next issue is the slow DNS lookups. The DNS, the common name used to match server or service names with the internet address that routes a network request. For commonly used names, the matchup is probably already stored in the system's DNS cache, and the lookup is quick. For less commonly used names, the matchup may be stored in a more distant cache, such as the root server of the top level name, such as .com, .org, or a national route such as .uk. Each DNS server along the path checks its cache before making a request to the next server along its path. The next server then checks its cache, repeating the process. If the lookup is slow, there may be a slow link along the path or a slow or overloaded server. To address this issue, your local network administrator can reconfigure local routers to shift requests to a faster chain of servers. Now, the main issue which is generally faced with all the person who are using internet or using the network technology of computer network is the duplicate static IP address. On a network, no two system can share the same internet address. If there are duplicate internet addresses, neither system can access the network reliably. The addresses for most network devices are assigned when dynamic host configuration protocol boots up the system on the local network. DHCP maintains a pool of addresses assigned to a local network or organization, assigning a different addresses from the pool to each system. Workstations are not assigned permanent addresses but receive one for a limited time from DHCP. Systems re-request before the time runs out and usually receive the same address. If the system shuts down without re-requesting and the time runs out, it loses this address and may receive a different one upon startup. The DHCP administrator may assign a static IP address to some network devices such as printers or web servers because external systems won't be updated if an address changes. One issue is users sometimes set up a private web server to support a hobby, allocating a static address without informing the network administrator. Both share a DHCP server in either an organization or home network. So if the static address matches one assigned by DHCP, it disrupts the network. Exhausted IP addresses. Internet addresses are in limited supply. Each service provider is given a supply based on the expected number necessary. Most familiar are the IPv4 addresses, which were originally thought to be adequate. So every system could be allocated one. But with the proliferation of cell phones and other devices, it's been necessary to move to IPv6 with 128-bit address for some networks. A widely used method to stretch the supply of addresses is network address translation, a feature often built into routers. Each is assigned a single internet address allocated from the worldwide set of addresses. Its internal DHCP server allocates private network to system on connected local network, usually an Ethernet or wireless network. Here are some images depicting the various issues in computer networking. IoT, big data, data science are also becoming increasingly common issues that need to be addressed in the field of computer networking technologies. Thank you.